Okay, so let's look at the last four questions on the kinematics review sheet. So number 15, a student standing on the roof of a building that is 88.5 meters tall drops a doll that looks amazingly like a physics teacher over the edge while he chuckles to himself. Keaton, you shouldn't be doing this. How long will it take for the doll to reach the ground? All right, so what do we know? He drops it. Notice it's a he, eh? Female would never do that. So if he drops it, VI is 0. A, gravity, is 9.81 meters per second squared down, of course. And it says the building, delta D, is 88.5 meters, and it goes down. And the question wants to know how long? Delta T. Let's see, what equation? Maybe delta T is equal to VI delta T plus 1/2 A delta T squared? And the VI is 0, so this term disappears. Rearrange for delta T squared, 2 delta D over A. So 2 times 88.5 meters divided by 9.81 meters per second squared. I didn't put any negatives in because everything's going down, so I'm going to call down positive. Okay, so you get t squared to be 18.06. Take the square root, 4.25 seconds or something there about. I'm doing it in my head, so maybe I should check. 2 times 88.5 divided by 9.8. I might have lost the 1. Square root. Sorry, so it's really 2.4. Yeah, 2.5. Okay, I didn't round too much. Number 16. A boy throws a ball straight up to a height of 20 meters. So there's some VI that we don't know. Whoops, it is not 0. He throws it straight up, and it's going to go up until it stops. This is 0. And it says it goes up to a height of 20 meters, so 20 meters up. Why does it stop? Because gravity is acting on it, and that gravity is down. Okay, with what velocity does he throw the ball, and how much time elapses? So first, with what velocity? I want VI, I have VF delta D and A. So VF squared is equal to VI squared plus 2A delta D. Rearrange for VI, so VI squared is equal to VF squared minus 2A delta D, but this goes to 0. So VI equals negative 2. Now there's an up and a down, so call down the negative, not because usually up is positive. So negative 9.81 meters per second squared times 20 meters, right? And it's a good thing that gravity is negative, because then you're not taking the square root of a positive number. So 2 times 9.81 is 19.62 times 20 should be 3,924. Take the square root, 19.809 meters per second. Excuse me. Okay, and of course, that's me scratching it. Of course, that'll be up. All right, so that's part A. Part B says how much time elapses from the time he throws it until he catches it. So you could find the time to go up and then double it. So we now know the initial velocity, we know the final velocity, we know acceleration. You could use A equals VF minus VI over delta T, and if we're finding the time up, the VF is 0. So delta T up is equal to negative VI over A. So delta T up is equal to negative 19.809 meters per second divided by negative 9.81 meters per second squared. And this should be pretty darn close to 2. I think it's 2.019 seconds. So then the total time would just be 2 times that. So 4.038 seconds is the answer to 16B. 17. A student drops a pumpkin off the Princess Margaret Bridge, which is 122.5 meters above the water. How long before the student hears the splash Okay, there are two parts. One is the pumpkin falling. The other is the sound coming back. So the student drops the pumpkin, VI is 0. The pumpkin is going to accelerate due to gravity, 9.81 meters per second squared. The distance that it falls, 122.5 meters. Gravity is down. The distance it is falling is also down. For the sound, it's a VAV, and I tell you in the question, the sound is 340 meters per second. The sound has 122.5 meters to also travel, and the question wants to know how long. So you need to find the time for the pumpkin, the time for the sound, and then add them together. Okay, so delta D is equal to VI delta T, 1/2 A delta T squared. This goes to 0. T squared for the pumpkin is equal to 2 delta D over A. So 2 times 122.5 meters divided by 9.81 meters per second squared, and take the square root. So 245 divided by 9.81. Take the square root. You should get a time for the pumpkin to be 4.9975 seconds. It goes on 45093. I round it. For the sound, you can just use VAV is equal to delta D over delta T. So delta T of the sound is equal to delta D over VAV. So 122.5 meters over 340 meters per second. So delta T of the sound is equal to, what did we just say, 122.5 divided by 340, 0.36029. Add the two times together to get your total, 5.35775. I rounded that last digit. Okay? Number 18 says, a rock is dropped from the bridge that's 40 meters above the water surface. It slows down instantly upon hitting the water. So here's the bridge, here's the water, here's the base. And it says it's 40 meters above the water surface. So this part, the delta D is 40 meters. It's dropped, so VI is 0. It's falling, so gravity is 9.81 meters per second squared. Down, down. And then it says it slows down to a quarter of the speed when it hits the water, and it sinks at that speed. So that's going to be our VAV, and our VAV is going to be a quarter of the speed with which it hits the water. In other words, a quarter of the VF that it strikes the water with, which we don't know, but we can find. It takes 4 seconds from the time it was dropped till it lands. So this whole thing is 4 seconds. So that means the time in the water will be 4 seconds minus the time in the air. Okay, but we don't know the time in the air. So the first steps are to find the time in the air and the VF. So time in the air, you can do delta D is equal to VI delta T plus 1/2 A delta T squared again. This goes to 0. T squared is equal to 2 delta D over A. So 2 times 40, which is about 80, divided by 9.81 meters per second squared. Take the square root. 40 divided by 9.81 times 2. Take the square root, 2.857 seconds. Okay? And so then this time will be 4 minus that. So this time down here then is 1.1443 seconds. Okay, and now we need to find our VF, so we know VF squared is equal to VI squared plus 2A delta D. This goes to 0. VF squared is equal to 2 times 9.81 meters per second squared times 40. VF squared is equal to 80 times 9.81. Take the square root, 28.014 meters per second. And so this speed is a quarter of that. So times